Hello all. In this video, we're going to look at various different definitions of what artificial intelligence is and are the different pieces of it that we might be interested in. We're also going to take a look at what AI researchers do in a little more detail and on some of the other disciplines that AI has a close relationship with. We'll try to identify some big themes and we'll also talk about what model we're going to use going forward for how to think about AI problems. All right, so let's start with defining artificial intelligence. This is actually harder to do than you might think, and there are lots of different definitions that have been put out there. Our textbook says that artificial intelligence is a field that studies the synthesis and analysis of computational agents that act intelligently. So they are focused on the creation and the analysis. That's both important pieces of what we want to do. We will create AI systems and we will analyze them to see how well they work. And we are looking at computational systems. We are also, Poole and Mackworth are particularly focused on acting intelligent, which is one piece of how we might define artificial intelligence. But I have this table here. This actually comes from the other textbook. I'm going to see if I can put this all in one page. There. This actually comes from the previous textbook that I used to use, but I really like this way of thinking about different dimensions of what we're doing. So on the one dimension here, if you notice, the upper row is talking about thinking, and the bottom row is talking about acting. And then in the vertical dimension, we have acting, behaving humanly, like a human, and we have behaving rationally, which is different. Humans are not always rational. So the question is, which part of that is the part of AI that appeals to you? Because people in AI work in all these quadrants. The thinking humanly, they're talking about, I like these quotes. They go back in time, but these are some of the big names in early artificial intelligence. The exciting new effort to make computers think, machines with minds. I think that captures like the thinking humanly, because when we talk about things having minds, we're typically talking about humans. These days we might extend that a little to include animals of different kinds of more simple minds. But back in the times that Haugen was writing, he was really thinking about human minds. The automation of activities that we associate with human thinking. Again, thinking like a human being. If I go down to acting humanly, we stop thinking about what's going on inside the head and we look at behavior that we can see from outside, creating machines that perform functions that require intelligence when performed by people. This tends to be a definition that kind of resonates with me quite a bit. So we compare the behavior of the AI agent to people. The study of how to make computers do things at which at the moment people are better. That also fits, and that's also one of my favorite definitions. Thinking rationally, the study of mental faculties through the use of computational models. So this is focused on how humans do the rational thinking that they do, the study of computations that make it possible to perceive, reason, and act. So again, this is focusing on faculties and computations. It's a very mechanistic view of what it means to think rationally. And being rational, making the right choice, is kind of one of the definitions of rationality. Making the right choice is a key kind of underlying theme here. Acting rationally, computational intelligence is the study of the design of intelligent agents. So there we're just talking about agents that when we look at them, they appear to be intelligent. They make the right choices. They do things in a way that we associate with intelligence. AI is concerned with intelligent behavior and artifacts. Again, all of these people are big and important people. What do I see as key here? Making computers do tasks that we consider to require intelligence in humans or animals. So animal behavior is complex, and simulating animal behavior is actually an excellent task for an AI system. Making computers do tasks that humans or animals are better at, to explore how to make systems do them better. Studying intelligence through the lens of how we can make computers behave in intelligent agents and intelligent artifacts. Those are two different terms that we're going to keep coming back to. I have this story that I included in here, which is that many, many years ago, I was grabbed while I was walking through a hallway at a conference by a journalist who had come to ask what this conference was all about. And they grabbed two people. We weren't together. The other one was a big name in AI, who I won't name. I don't even know if I remember exactly who, but I recognized them at the time. They were a big name in the AI community, and I was just a lowly graduate student. And they asked us, what's AI anyway? And the big name gave a definition, somewhat jokingly, that I actually kind of love, which is AI is what we can't do yet. And I say that because there are lots of things that were developed as a part of AI that have gone on to be separate disciplines or separate algorithms that people don't really associate with AI anymore. Things like path planning, finding directions to get from one place to another. That was a big AI problem, and people worked on it for quite a long time. And now it's not so much considered a part of AI. So once we know how to solve a problem algorithmically, and this is less true with machine learning, but maybe that will change over time. But when we come up with an algorithm that does a really good job solving a problem, we tend to say, oh, well, that isn't intelligence. That's just an algorithm. And we move it out of AI. This happens with things like game playing. Chess playing systems, that was at one point seen as the epitome of the goal of AI, was to get a system that could play chess. And then once we got them, we said, oh, well, that's not AI. That's not enough. And so what we're often comparing to is this idea of the ultimate AI, artificial general intelligence. And these are artificial beings. You see them in science fiction a lot, and in reality, not at all. Artificial beings in a real world or virtual. They may be embodied as robots or androids, or they may be just a computer system that we accept as full beings with presumably rich internal lives. This is great in science fiction. It's hard to do, and no one has done it. So most AI researchers, they are not really looking to create artificial general intelligence. It's too hard and too complex. It's too ill-defined. So I will say that that's not really what most of us do. But as I noted in my earlier video, Silicon Valley has gone a bit nuts, thinking that the models that they're building right now are just one little step away from artificial general intelligence, and they're pouring a lot of money into it. So who knows what they're going to come up with? I am myself a bit skeptical that they're going to find success. I think they might hit the limits of what the models that we're currently working with are capable of without hitting on what an artificial general intelligence would look like. All right, so what is it that AI researchers want to do? Many, many, many different things. AI people do all kinds of work. Does not bear any resemblance to other people in the same overall field. And there are a lot of different subfields because of that. So some people just want to build cool software that can do new things. Others want to make software that tackle real-world problems and that deal with the complexity of real-world problems. So they're really interested in this, like having things that sit in the real world and the challenges of solving problems like that. Some people, as I said before, they're interested in the nature of intelligence or creativity or decision-making, planning, learning. They want to build computer systems that get at those things in a way that helps us to understand better what we mean when we say planning, learning, creativity, intelligence, consciousness. All of these loaded terms that people toss around, and we want to be real careful that we understand exactly how they're defined. And there are people out there trying to work on improving our definitions and understanding. Pushing the boundaries of what computers can do. Maybe they just want to make a computer that does a problem that computers haven't solved well before. That's also perfectly fine for an AI motivation. Or some people want to model human or animal intelligence in order to better understand intelligence itself. And that includes a lot of people who are interested in exploring animal behavior and simulating it as a way of understanding biological and psychological aspects of behavior. So AI is so related to so many other fields. I'm again going to make this all on one page. I have a partial list here of fields that AI relates to. Philosophy, both in terms of logic, but also in terms of philosophy of mind and AI ethics. Mathematics is the underlying rules that help make these things work. Machine learning is all about mathematics and statistics. That's what it's built on. Linear algebra in particular. Economics, utility theory, decision theory, game theory, those things are important, and people work within the context of AI on those kinds of problems. Neuroscience is involved in structures of the brain, which people simulate. Cognitive psychology, which also is, those people who are interested in studying intelligence. And so they might build computational models. Psychology as well, computer engineering. We need big systems to run some of these, and sometimes we want special purpose hardware. And so computer engineering is the place to go for that. Control theory and cybernetics. A lot of this work has to work, is more in the engineering side of things. So it's like, how do you build devices that regulate themselves, that seek a low energy state, that do optimization naturally, that are robust in the face of the variety of inputs they might get. These sort of things are really important within the field realm of robotics, but also in other AI systems as well. And linguistics, natural language processing, is naturally connected very strongly to what we do in linguistics and how we study human language. I am in a separate video going to go through these big themes in artificial intelligence, but one thing I'll say is all of these different areas I'm going to talk about, there are these cross-cutting themes. And you'll see them come up across all of these problems, and there are also interesting things to think about. So large-scale problems, scaling things up to actually tackle the real world or the real amount of data we have about the world, and big data as an important tool, but also as an issue to be managed. Ethical considerations go across the board. And human AI interaction. So how can we interact with computer systems using AI to make our interactions more natural, more easy? And there's also sort of the more extreme versions of that, human-robot interaction and brain-machine interfaces, so things like implants that people use to do various spectacular things. Those are on the cusp and the edge of artificial intelligence. We are, during the course, going to focus on this idea of an intelligent agent. It's a way to bring together everything from, a program that plays chess to a robot to a machine translation system and try to make some sense of them, is to imagine that we have an agent. And the key ideas here are that agents exist separate from their environments, but in an environment. They can sense that environment, they can make decisions, they can take actions in that environment, and they live within a constant cycle of sensor, decide, act. This doesn't quite fit some of the ways we talk about machine learning, but in AI, we're more interested in how you take the machine learning and you plunk it into an agent and have it actually play out. We also have to think about various things like performance measures, like how do we evaluate an agent's behavior. And we'll talk about some of these other things like in later terms as well, like how do we define a rational agent? How would we know that something's rational? How can we evaluate and assess environments and their properties? And we'll talk about that in a later video. So for right now, I'm going to pause. I hope this has given you a sense of some of the breadth and scope of what AI can be. We'll talk about those big themes a bit more and dig into some different areas of AI. And then we'll have lots of further opportunities to explore some and then maybe all of these different areas in your own projects.